syllabus which we are going to cover in this training session. So in module 1 we have some basics of networking, like ports, basic concepts of networking, okay, like ports and protocols and OSI model. Yes. And in the second module we have a infrastructure. So we just discuss about all infrastructure, okay, of routing switching. And third module we have a network operation. In this we cover network operations, okay. And in 4 we have some network security topics. We'll cover these topics in network security. And 5 module we have some troubleshootings, okay. And for practical purpose we use Cisco Packet Tracer. Do you know about Cisco Packet Tracer?
Yeah, I've used it a lot in the
Yeah.
past.
Okay, okay, good. So we'll cover our topics with Cisco Packet Tracer. Okay. So let me stop. So first, what is network? Simply, I'm going to define network. Any connection between two devices, like this is your PC. My screen is visible, the whiteboard for you.
Yes.
Okay, and the PC. If these two PC are connected to each other in any way, uh, with wire, with wireless, any medium, and they are communicating to each other. They are sending any information to each other. They are, so that can we call as a network. Okay, simple two PCs. And if
Yeah.
I have a multiple PCs, maybe a multiple PCs connected, and that connected with a switch, and that can be connected with a router, and that can connect with firewall and then ISP. That can also be a network. Okay.
Yeah.
And the terminology to form a network, the devices we use, that called networking. Okay. So today we are going to cover a topic that is OSI. Maybe you know about that. Okay.
Yeah. Layer
OS.
1 through layer 7.
Yeah. Let me erase this. Mm, yeah. OSI model. Okay. Basically, what is OSI model? OSI model is a reference model. With the help of OSI model, we got to know how data is traveling, how data forward from one node to, like this is Kate. Okay. You are using your PC, and this is Rahul. I am
Mm-hmm.
also using my PC. How we both are connected to each other. We are connected with our PC. We are using internet. We are using some application like Zoom application. Okay.
Yeah.
So these both are working on their end, and we are communicating to each other. So with the help of OSI model, we got to know how data is traveling from this node to this node. I mean, Kate to Rahul, Rahul to Kate. Okay. The voice communication, the Zoom communication, all of it. Okay, let me open. Just- Okay. Okay, sure. So my screen is visible for you, the OSI layer.
Yeah, I can see it now.
Okay, good. So as I explained you earlier, OSI is just simply a model which is a reference model. It just explain how data is traveling from one node to another node. Okay. And the full form of OSI is Open System Interconnect Model. It's just simply developed by international organization for standard organization. And as you know, it consists 7 layers, and each layer has a different work. It's just a separate functioning and working for a dedicated
Mm-hmm.
work. Okay, and why we come with OSI? Before that, we have a TCP/IP model, but in the TCP/IP model, we have a issue. We can't communicate to different vendor. if I am using a HP laptop or you are using a Dell laptop, so these two devices can communicate to each other. So
Hmm.
that's why we come with the OSI model. Okay. So different vendor can communicate to each other. So every communication now happen on the basis of OSI model. Okay. So as you
Okay.
know, we have a 7 layer in OSI model.
Yep.
As- uh,
Physical, data link, network, transport, session, presentation, and application.
Yeah. So the upper layer, these upper three layers like application layer, presentation layer, and session layer, basically handled by the software engineers. Okay. But we have to understand this, how it's working and what the working of this. But the upper 4 layer, these are basically maintained by network engineers. Okay. So the transport layer is the heart of OSI. It plays a very huge role in the networking and every communication. And we have three upper layers like network layer, data link layer, physical layer. So our networking device like router, firewalls are working on network layer. Okay.
Hmm.
We have switches like a layer 2 devices. It's called switches. Have switches working on data link layer, and last we have a physical layer like data is converted in binary bits on that, and we connect our devices like connectors, pins. So these are all happens on the physical layer. Okay, so let me explain you the working of these all layers. Okay, first we have a application layer. Okay, so as you know from the application is responsible for providing network services like I'm communicating to you. Okay, and we are in a Zoom session. So if I have to communicate to you, I need a application, any medium, a
Right.
laptop, software like I can connect with you with the help of web browser, with the help of Zoom application. It can be any other medium. So you can understand that it just provide a user interface to communicate the services. Like I'm
Right.
simply accessing a web page from a server. So what I have to do, I have to access HTTPS service. How I access HTTPS service? With the help of web browser. It may be a Chrome, it may be a Firefox, and any other, maybe Microsoft Edge, any browser. But I need a application. So in simply
Right.
word, it just provide a user interface to communicate the service. Like I just want to send a mail to you. Okay, I have to use a mailing service. So what I do, I just open mail from browser. I can also use a mailing software like Gmail, Outlook, anything.
Oh, okay. I got you.
And ports is simply like a communication channels. Whenever we are communicating to each other, so it's just a communication channel. Okay, if I have to I am using I have to access https service. So I have to communicate on ports in networking terms. So if I'm not going to write anywhere in the communication, there is nothing like HTTPS. So for the HTTPS, we have some port. So in the networking term, we mention as that as a port. Like I am communicating on 80. So the communication happening on HTTPS. So we have some ports. 0 to 65535 is the total ports. Few are reserves and few are open client ports. Okay, we'll explain further in upcoming.
Yeah.
Like you can see like if I have to access FTP service, so I'm just accessing by this a web browser. Okay, searching like this. The same way I have to access FTP, I get the FTP server with the help of this. The same way we are going to access any services in our browser like HTTPS google.com. So that can also like work on application layer with the help of application layer. These are
Okay.
few ports which is basically used on application layer. HTTP is also used for accessing web services. FTP is file transfer protocol, which it is basically used for accessing file services. SMTP is using for mailing services. A telnet is used for
Remote.
remote. And the same way we have TFTP. TFTP is also like a FTP, but what's happened in this we need to it's just secure from FTP. In this we have to need a index of data. In FTP we can surf, but in TFTP we have a proper destination where we can go and find that data. The same way we have a SSH to get the access of networking devices. Okay, SSH
Yeah.
is basically secure and telnet is not secure. The same way we have a HTTP. It is also used for wave access, and the port number is 80 for that. And the same way we have a HTTPS. HTTP is not
Okay.
secure. HTTPS is secure. You
I
can
have a
check by
question.
your own. Yeah. Yes.
And for all of these services, these ports are statically assigned. So they're supposed to be the same ports on each device, basically. Is
Yeah.
that what you're saying?
E- Every service having a particular port for that.
Okay. So it may not always be the same port number.
Yeah. In networking term, we are talking about HTTP. So that's mean in networking, we are talking about the port number 80. Okay. If you are doing any troubleshooting or anything else, so at that moment, what you see in the packet capture or all of our places in networking term, the port number 18, you can't see anywhere as a HTTP. You have to allow somewhere to you have to allow a port 80. So every moment we have to understand the this port is using for which services. So you have to remember approx to 20 mainly 20 and 25 ports. I will share with you later that ports. Okay.
Okay.
Yeah. So like this, we have a data on application layer. Now if application layer is communicating on any port, so we can assign this port like this 80, 21, maybe 25, 53. After application layer, data comes on the presentation layer. So basically what presentation layer did, just deal with the extension, how to present the data. Okay, I am sending a video to you. Okay, and that is traveling in our network. So that video is not travel to you in the same way, like a MP3 way, or like in a that video. It just converted in a standard format. Okay, that
Right.
can be a ASCII, EV, encoded binary coded decimal interchange. So basically, what happens on the presentation layer is just present the data. Okay, how to, like I'm sending
Or
a
like a
data to
file
you.
extension?
Yeah, like I have a exe file. Okay, so data is traveling in a network. It's not traveling in a exe. It just travel in a binary weights. But at the time it's received on you, you just want to see that file in a exe.
Hmm.
So it deal with the extension. It just basically convert data into a standard format. Okay, like we have some example like ASCII, EVC, DIC, JPG, MPG, BMP, MID, and BAV and MP3. And the basically
Right.
work of presentation layer, encoding and decoding. Like I have a basic format like I send hi. So it is not traveling like hi to you. It
Right.
just convert in another format. Okay, so at the end, if I am sending to you, I am a sender, you are a receiver. So it just encode on my end and decode at your end. Okay, and the same way the data is encrypt at my end and decrypt is at your end. And compression and decompression just decreases the size, so it can easily and feasibly travel in network from one end to another end. Okay,
Okay.
so now data comes from application layer to presentation layer. And now presentation layer 2, it's come on the session layer. So what's happened at session layer? As you know, at the time you just open a browser, and at the same moment you are using some YouTube, you are using any other website, you are using any other website, and the same time the all data is coming to you. But what's happened, it's just showing separate on window. YouTube is running on separate, and another google.com is running separate. So how it is running separate? On the basis of sessions. We have a session ID, and the data coming with the help of the session ID, and it is dedicated to particular session. So it will represent at the same place. As you know, sometimes you see you just logged in your bank account, and it will automatically terminate after 15 minutes. If it is ideal, you are not using, and in some scenario it will automatically terminate.
Hmm.
So at that moment, it just create a session. For that service, you just access a bank service, a bank page, online net banking with the help of HTTPS and then bank name. So at that moment, it will create a 15 minute session to you. After 15 minutes, it will automatically log out. So what happen at session layer? Session layer basically provide a connection, maintain the session, terminate the session, and establish the session. Okay. And why we need session? At the same time, we are managing multiple things. We are doing multiple things in our device.
Okay, I understand.
Good. Okay. As you see, session layer is responsible for establishing, maintaining, and terminating the session. And how it's happened? It's just happened with the help of session ID. For a specific connection, it's having its own session ID. Okay. Now data comes on session layer. Now session layer 2, it will go to transport. And when it's received on the transport layer, it's convert into a segment. Okay. And what is transport layer? Transport layer is the heart of OSI. And to remember transport layer, also remember transport layer is responsible for end-to-end delivery of data. You can see end-to-end connectivity of network and end-to-end delivery of data. And it is also known as the heart of OSI. Okay. And what's happened on that layer? It just basically identify the service. So how data is travel in network? It's used two services on transport layer. First is TCP, transmission control protocol, and another one is UDP. So the data coming from upper layers, the software layers, is just divided into two parts as per their requirement. Okay, as per their requirement, it can be a TCP, it can be a UDP. UDP is user datagram protocol and TCP is transmission control protocol. Okay.
Okay.
So what's happened on this layer is just simply first identifying the service, which service is coming from upper layer. Like if application layer we are using HTTPS, so it will use TCP at transport layer. It is basically use TCP. If I am using DSCP and maybe FTP, so it will use UDP. According to the service, it will use maybe TCP or UDP. And another hand,
Okay.
it's happening multiplexing and demultiplexing. Okay. And at when the data received on transport layer is just called as a segment. Okay. The packet called as a segment, and it's have a dedicated size for a specific packet. The packet, the data which is coming from upper layer, that called as a segment, and that can be a specific. It may be a 1460. And sequencing and reassembling. What's the sequencing and reassembling? If I am communicating to you, I am sending some message like, "Hi Keith, how are you?" At the time of network, it may be at the sequences.
Oh, okay, I see.
Yeah, it can see maybe sequence is disarranged. The hello is before the hi, and it this. Yeah. So what happened at the it just provide the sequence. It just manage that with the help of sequencing.
So,
It just mark that every packet as a sequence number, and it also
oh,
reassemble the data.
so it formats the data
Mm,
basically.
yeah. I have. Okay, I will show you. No worry. And also error connection is happen on this layer, and it also manage flow control, the control of flow, how much data another device is handle, so it will send that specific data, not over control. Okay, so we have TCP and UDP, which is work on transport layer. So this is the basic working of these two protocols. The TCP is transmission control protocol, and a first term you see TCP is connection oriented. The mean of connection oriented, it will take care of the connection. How? With the help of three-way handshake, four-way handshake. The mean of connection oriented, whenever it's just sending a data to anyone, First, it will send a SYN message to check the device is on or not. It can accept my data or not. It just handle that or not, and also share some information to establish a connection. That's why it is connection oriented. But in the case of UDP, nothing happen like this. It just directly send the data. Okay, it not communicate prior, just directly send the data. But TCP first make the connect, stabilize the connection, and then send the main data. In the TCP, we get the acknowledgement, like I send something to you, you are a receiver and I am sender.
Right.
When the data is received at your end, it just send a acknowledgement. Acknowledgement means that it just acknowledge, I received successfully that data, but whatever you share to me. In the case of UDP, there is no acknowledgement. The sender didn't know about the data is delivered or not delivered. TCP is reliable and UDP is non-reliable. Why? If my data is lost, UDP is not going to share that data again. As you saw, give you a very good example. Whenever we have a video call, okay, yeah, and we have a live streaming of anything. So in some moment, few packets, few voice, for few video quality can be dropped. It will not going to find again. It just goes, then once goes. But in the case of TCP, I am just simply sending a message to you, a mail to you. It not goes like that. Half mail reads to you or half not. I just simply text you on WhatsApp, hi, hello, how are you? And it maybe goes everything. It's just not like that, high delivered to you. But in the video streaming, we just get some blood print, the non-understandable voice. So in that scenario, some data is lost and that is not delivered again. And for these specific region, UDP is fast and TCP is slow. Because TCP take care of these all things, that's why it is slow. And they have dedicated port number for TCP and UDP. Like for TCP, we have port number 6, and for UDP, we have port number 17. And as we have a specific services which is used at application layer, like TCP handle HTTP, FTP, SMTP, HTTPS, FTP, but UDP handle DNS, DSCP, and TFTP. These
So what
all services comes from application layer. Yes.
so what kind of service would you use that would be assigned to UDP?
Okay. It's these are few services you have to learn, like you have to remember. The services which is reliable, like HTTP connection, FTP connection, and SMTP, these are reliable, so they will use TCP whenever they need to communicate. But you, in the case of UDP, that these are not reliable, so they will communicate UDP, because these services need to happen fastly, very fastly.
Okay,
Yeah.
I think I understand.
From transport layer, data come to network layer. When data comes to network layer, networking comes into our hand. As we use TCP, if the service use TCP, so then port number 6, then if you used UDP, then port number 17. Like it's just segmentation. I just send hello, how are you? So it will arrange that in a segment. Okay. I have a, in this 1, 2, 3, 4, 5. We have 5. You just create a segment for specific data, like one segment for hello, one segment for how, and one segment for r, and one for you, and one for question mark. Okay. I have this whole data, like a whole, like hello, how are you? You just create a little segments on the behalf of a specific segment size, that is 1460. Okay. You can understand segment as a chunks of data. I have a data in a very bigger size. I just create small chunks to deliver from one end to another end. Okay.
Wow.
And then in sequencing and reassembling, oh yeah, you see, I just send hello, how are you? But at
Right.
the receiver end, I receive you, hello, how are. It doesn't make any sense.
Right.
And it is using TCP. That's why it is arranging that data. But it is somehow using UDP. In some scenario, you see you are on a video call. Video comes first and audio comes later. So at that scenario, data is not arranged. But in that TCP, in the scenario of TCP, data will arrange in very proper
Oh,
sequence. So what it will
okay.
do, it just arrange that data with the help of sequence number. What's happen when data is sent? When data is sent, it will mark a sequence number, not showing in this PPT. What it's just showing like 1, 2, 3, 4, and 5. Okay. And if somehow it is, let me clear this. Okay. Now we have a sequence. This is 2 and this is 1. So we'll arrange that data with the help of that sequence number. Okay. Got it?
Yeah.
Okay. Good. Mm, let me erase this. Okay. Now what's happened? In V4 you see we have in this we have one. Let me use 1, 2, 3, 4, 5. This is message. And so what's happened, if any packet lost at the time of traveling, any packet lost, it just uh, simply send the sequence number of that packet, that segment. It just indicate that I need to you need to send this segment again. So by the
Okay.
help of this, it will just manage the error. Like I just sent 5 messages to you, one is dropped at the between of network, in the middle of network. So but we have marked the sequence number on that. So on the behalf of that sequence number, it will send to sender, you have to send that message again. So so at that at this way, it just handle the error, any kind of error. Mm, okay.
Okay.
Like this. If in this scenario the segment 4 is lost, so it just asks to again send us segment 4. Yeah. Now data comes from transport layer to network layer. As you see, network is basically responsible for providing the best path. Okay, I have to reach your home and I have multiple paths, multiple routes, multiple roads, but it will choose the shortest path, shortest route. Okay, and IP addressing is also happening on this layer, and IP addressing is called as a logical addressing. Okay.
Right.
Yeah. So network layer is responsible for providing best path, and path, you can say best path or path, but it will provide best path. Reach the destination. And logical addressing is also happen on this layer, and some devices work on this layer like router, firewall. Okay. And IP and and routed protocols also work on this, like IP, IPX, Apple Talk. Apple Talk now not we are not using, but before that we are using this.
Mm-hmm.
At this layer, now to if we have to send data from one place to another place, we need to use some routing protocols that can the packet can be route from one place to another place. I mean source to destination. So for that we use some protocols. It may be, like this RIP, routing information protocol, IGRP, OSPF, EIGRP, and BGP. We have also BGP, border
Mm-hmm.
gateway protocol. It basically used by ISP. Okay, so these few are routing protocol which helps us to forward traffic from one network to another network with the help of routing table. And at this layer, some few routed protocols work like IP. How data is forwarded from one node to another node with the help of IP address. And what is IP address? IP address is just a logical address of a device. You are using your PC, uh, that PC having an IP address, and that IP address just is a logical address of your PC. Your PC is identifying with the help of that IP. Okay, the same way we have a MAC address. What is MAC address? MAC address is a physical address.
Physical.
Yeah, physical address, and that is not changeable. IP address we can change easily, and it as per requirement it can change anytime. But physical address never change. And what is physical address? Is simply MAC address.
Hmm.
Okay, yeah. Let- Okay, as you see, we are using some logical addresses to send the traffic from one node to another node. The PC A having this IP and PC 2 having this IP. The same way we two are communicating on Zoom. My PC having its own IP. It may be something, and your PC is also having a IP. This like this. How where to me, where routed protocol and routing protocols works on these devices. RIP is also working on this, like RIP EIGRP configured on this. So it will help data to travel from one place to another place. Okay.
On the
And, and,
network.
and and
Okay.
that's the same way you are connected from your PC to this internet, and data is travel that way, and the same way travel from here. Okay.
Okay.
Yeah. Okay. But when data comes on network layer, it's called as a packet. Before that, it was a segment. Now it is
It was a
just
packet.
packet. Now we have a data link layer. Okay, so what data link layer do is just forwarding traffic within a network. Okay, it's just simply divided into two layers. One is LLC and one is MAC. So few services work on LLC. It's talks about WAN protocol like triple P, HDLC, and frame relay. And another one is work on MAC address, that is media access control. You can check. You can also check your in your PC. You have you have a MAC address of your PC. That is a physical address. That is a 48-bit number, and it also help to detect error. Okay, device working on data link layer switch. On okay, we have some devices which is work on data link layer. It can be a switch. Switch is a layer 2 device. Okay, and bridge and NIC. Okay,
Okay.
yeah. Okay. At data link layer, we run CRC. CRC is simply used for error detection. Okay. Cyclic redundancy check. It is just an algorithm which is used to check error. If we have any error in packet, so it simply drop at that level, at the second layer. That is a data link layer. Okay. Because I send something to you, and if that is corrupted and the information is not proper, so it just not delivered to you. It just simply dropped in network and asked to redeliver. Okay, so in the local communication, it also use MAC address. When the communication happen between two devices, it uses a logical address and also use physical address. What is the logical address? Address is that IP address, and physical address is the MAC address. That is
Right.
48 bits. Yeah. Now, when data is received at data link layer, it called as a frame. That specific data called as a frame. Then we have a physical layer, the last layer, upper layer, responsible for electrical, mechanical, and procedural checks. Basically what's happened in that, your PC is in some scenario your PC is connected from a Ethernet cable, okay, and maybe a fiber optic cable. So that cable is a work on a physical layer. What's happened on physical layer, data is simply converted in binary bits and sent through the Ethernet media, which is the any media which is connected from the device. So we have some device which work on this, as you know, hub, repeater, cable, modem, pins, connectors, etc. Okay.
Switches.
No,
Hmm.
switches is work on data link layer.
Okay.
Only hubs work on physical layer. Hubs are not intelligent device. Switch and router are intelligent device. They have its own memory, and it will take decision on the basis of that memory. But hub doesn't take any decision. It simply forward the data.
Oh, okay.
So at physical layer, how data travel? How data travel simply in the binary bits. That is a format of 010101. It's just a computer language, as you know. So at physical layer, data convert into bits and forward to the media, which is so now the application A is a sender. So data travel from sender from a application. So it will just deal with the application layer, then come to presentation layer, and then session, then transport and network and data link layer, and then it comes to physical, and that physical to send to this end. Now when it's received on this,